All right, let's talk a little bit about functions. Like we were saying, the functions are special, if you will, special types of equations. They don't necessarily even have to be equations, but a lot of these equations we've been working with, the lines, the others on the worksheet there, have been, or we could have designated them as functions. So let's talk a little bit specifically about a function. Well, before we start with function, let me talk about relation, because they'll talk about it first. Before we get to function, a relation basically is a correspondence between two quantities. Which a lot of times an equation does that, right? It relates the x value to the y value, but a relation can be anything. It can be two specific things, like I could relate students with their grade point average. I could relate the time of the day with the temperature at that particular time. So it could be just about anything. Like I said, an equation that relates this x value to this y value. That's what we'll mainly be focusing in on. But anyway, that's what I'll mean by a relation. Okay, and there's different ways that we do that, and we've done most of these ways already. But let me just show you here a couple of examples of relation. Like I said, we can do the time and temperature thing. So at 8 o'clock, it was about 70 degrees. At 8:30, it'd come up to 72 degrees. And then 9 o'clock, it turned into 75 degrees. Okay. So that's just an example there of relation. And you can list it out by a table like that. Or, this way is familiar with us. We can also do kind of an ordered pair thing. 8 with 70, 8:30 with 72, 9, 75. Okay, same thing we have been, just as an ordered pair table, something like that. One thing, though, we haven't done is what's called a mapping. So if they ask for a mapping, here's kind of what that means. I'm going to change up the things, though. Let's say on the left we got Jack and Jill, and then on the right we've got some courses. Okay, so Jack, he's taking Chem 160, English 110, and History 121. Jill's, though, taking Math, English, and History. Okay, that's called a mapping. It just shows your correspondence with arrows, and that's a mapping. So if it asks about a mapping, that's what it means, okay? Or a relation can be, like I said, with an equation. Doesn't this relate two numbers, two quantities? It relates the x value to the y value that goes with it. X is 1 would go with y is 2. X is 3 goes with y is 6. Okay, so, and that's, of course, the relations we'll be most interested in here as we go along. Okay, all right. So this is how we'll start anyway with some of this stuff. Now, another thing let me mention here is pretty much on all these, the one on the right, the left, my other right, the one on the left is kind of your input value, and then the output is the one on the right here. Pretty much, on these the pairs and the mapping anyway. The input's here, and then the output is on the right. Input's on the left, output is on the right. So We put in 8, then we get out the 70. We put in Jack, and the outputs are Kim, English, and history. Now, for this one, which would you say input and output? On this one, with the way this equation's arranged, wouldn't we say input is the X, the output is the Y? Because I'm going to put in X value 1, X value 2, and then out comes the Y out of that. Okay? All right. So that's the input and output thing. We'll use that terminology. Okay. Well, so that's relation. Here's then what we mean by a function. A function is a relation in which each input value corresponds to exactly one output value. Kind of a mouthful to say, but it's not that terribly difficult to understand, I don't think, but that's what I mean by a function. A function is a relation in which each input value corresponds to exactly one output value. So you get, for every input, you get one output. Okay? So let's go through a couple here and ask ourselves, are these, there'll be relations, are these relations functions? Number one. You've got an input, an output table, so we've got input of 7, output of 6, input of 8, output of 4, input 9, out comes 2. 7, 6, 8, 4, 9, 2. Is that a function? Well, yes, it is, yes. Because how many outputs does input 7 go to? It goes to 1. How many outputs does 8 go to? It goes to 1. How many outputs does 9 go to? It goes to 1 output. Okay? So, yes, this is clearly an example of a function. All right? Let's do a mapping here. Is this one... got 8 and 9. Inputs are 3, 4, and 5. The outputs are 8 and 9. 3 goes to both 8 and 9. 4 goes to 8. 5 goes to 9. Again, inputs on the right, outputs on the left. Inputs on the left, outputs on the right. Is that one a function? No. Why not? Yeah, the 3, input 3, is matching up with 8 and is matching up with 9. So that one has one input that goes to 2 different outputs. And so that's a contradiction to your definition of function. Each input can only go to one output. So that's what we're looking for. Is there an input that goes to more than one place? Here it didn't, here it did. What about this one? So it'll be the same thing on the table. You know, if we did it in a table, it would be basically the same. But here's another table for you. Input and outputs. All right, so input is 6, output is 9. Input is 8, output is 4. Then 10 input matches up with also 4 output. And then 12 input outs with 9. 6, 9, 8, 4, 10, 4, 12, 9. Is that a function? Oh, we got some yeses and nos there. Yeah, this one's a little trickier, I guess, but think about the definition. Each input goes to one out. How many outputs does 6 go to? It goes to 1. How many outputs does 8 go to? It goes to 1. How many outputs does input 10 go? It goes to 1. 12 goes to 1 output. Each input does go to 1 output, doesn't it? Yes, it does. Yeah, on what matters on functions is you don't have duplicating inputs. Here, we have duplicating output. That's okay. Matter of fact, all these could be 9s, and it would still be a function. You can duplicate outputs. You just can't have duplicate inputs, you see, that to be a function. The input, you can't have duplicate inputs. So duplicate outputs, that's okay. You can have all 9s, all 4s, doesn't matter over here, so long as you only have each input once going to, each input goes to one output. Okay? All right. Number 4. Ordered pairs. 3, 2, 4, 5, 6, 10, 3, negative 2, 4, negative 5. That's my inputs and outputs for this relation here. Would that be a function? Why not? You got 2 inputs going to the same, same inputs going to 2 different outputs, don't I? I've got 3 going to 2, and then I have 3 going to negative 2. I've got also 4 going to 5 and negative 5. So yeah, that is not going to be a function. An input's going to more than one output. So again, you can't have duplicate inputs. Same thing. But on ordered pairs, again, remember, your input's the first, your output's going to be the second. Okay? So that one is not a function. Okay, well, let's talk about a couple of equations. Let's go back to the y equals 2x one. Is that one a function? We'll say more about equations more as we go along here. That's kind of where we're building up to. But just to think about it all the way through here, you can you can think of it in kind of in a table format here. The x, again, the x's, we're usually saying those are the inputs, and then the y's are the outputs. So let's think about any x I could plug in. Random x, if I choose x to be 5, can I get a y value other than one y value out of that? Pretty much locked in. If x is 5, it's locked in to be what? Y. Y's got to be 10, doesn't it? Is there any other value you could get out of 5? Don't think so. Don't think so. Negatives, same way. If I choose a negative value, it's locked in. Y then would be locked in to be negative 12. And that would be the only value y could be in the case of x is negative 6. So is this a function? Yes, it is. Any x value I input, the y value, 0. X is 0. What do I get for output? Be 2 times 0. That'd be 0. So if you put in, yeah. Okay, yeah. Now that's I see what you're saying, thinking, I think. You've got the x input and the output's the same. That's okay. That is okay. You've got the input and the output matching, but that doesn't violate the function rule. The input x goes to the output, the same output, but that's okay. That x only goes to that output. There's not another value. Okay. All right. Okay. What about this one? What if we had x equals the absolute value of y? And again, just kind of thinking about x and y values. Again, if we're taking the x as the inputs, the y as the outputs, here is what to note. Let's say I choose x to be 3. Well, that sets up this equation, doesn't it? And do you see something there that y could be obviously 3, but y could also be negative 3, couldn't it? Yeah, if x is 3, then the y value could be 3. But if x is 3, then the y value could also be negative 3 because we're doing the absolute value thing, aren't we? So is this a function? No, because we've got one x value that goes to two different y values or output values. Okay? Question? Huh? Oh, I think you're thinking the absolute value of 3. If I had chosen the y value, yeah, the answer would be 3. But what we're saying is I could have the y value. Wouldn't this be true? This one right here? If y is negative 3, doesn't x come out to be 3? Yeah. So that's where we'd be plugging in, and that's kind of the issue here. But anyway, yes. There are two possible y values that would give us x value of 3. So it's not a function. Okay? All right, well, kind of as you can tell there, it really kind of boils down to a certain type of equation. Maybe I could, if I had y minus x squared equals 2, is that a function? Well, turns out that one is. That one is going to be. We can do the very same thing here with the table. If you got x is 1, then y would have to be 3, wouldn't it? Add 1. And that's the only value the y could be. Same thing, we do 2 and 3. See, 2 would be 6. 3, real quick, would be 11. You can check me on those, but I think that's right. But yeah, each x value goes to only one y value that's locked in. Now, this one's a little different than the other one so this one is a function. This one's in a little different format. However, couldn't I very easily, the other one I had was y equals 2x. Couldn't I make this one look a lot more like that one by just moving this term over there and make it y equals add x squared? Okay, so yeah, this is this is kind of the thing on equations and functions. If we're taking x as the input and y as the output, if you can put it more like in this form, a y equals, it's going to be a function. Okay, and so for that reason, we have. Let's talk about function notation. Function notation. What function notation does is it takes a function, say y equals 2x or y equals, what was that, x squared plus 2. Both of those are functions. And we have a function notation. What that does is it, instead of y, we replace the y by this function notation. The function notation goes like this: f parentheses x and then equals 2x. So I'm replacing the y by this f parentheses x notation. Here's what this means. It's read f of x. That's how that's read. What that means is the f is the name of the function. F is the name of the function. We're calling this function f. And then the parentheses x stuff, the x is just your input value. F is the name. And the parentheses x, that is playing the role of your input value. Okay? Now, since this one's a different one, let me just say over here, a lot of them will call f of x, but they don't have to be called f of x. This one, let's call this one g of x. But the point of this is, if I see this notation, either like this or f of x equals g of x equals, if you see that, it's locked in to be a function. This is function notation. If it's in function notation, it's a function, okay? No two ways around it, but all we're doing is we're replacing the y value by this function notation, f of x, g of x, h of x, whatever the case may be. Okay, so f of x and y, those are going to be synonymous. Keep that in mind as well. Okay? All right. So that's what we mean by function notation. All right, here's another example. F of x equals 3x plus 1. Is that a function? Yes, it is. That is a function. What we'll have you do on these is, starting out anyway, is evaluate functions for certain things. Let's evaluate this. F of x equals 3x plus 1. Let's evaluate f parentheses 7, or the way we really say that is f of 7. What you have to understand there is what this means. This is, again, the name. This is the input. So what is this telling me? That's telling me the input value is going to be 7. X being the input value, this is telling me I'm going to input the value of 7. Well, what does that mean? Well, that means, like I've done here, x is replaced by 7. So wouldn't that seem the reason I need to replace the x by 7 here too? Yeah, so I'm just going to input if it's f of 7, I'm going to input 7. So that's going to be 3 times 7 plus 1. That's 21 plus 1 is 22. So f of 7 is said to be 22. Okay, so you can see how this works. If I want to do f of negative 5, same deal, isn't it? Except the input value is, instead of 7, it's negative 5. So what's f of negative 5? Well, I'm going to input, instead of 7, input the negative 5. Of course, evaluate it. 3 times negative 5 is negative 15 plus 1. So you get negative 14 in that case. Okay? So that's kind of how that works. All right, but let's do another function. You said you can have not only f functions, but you can have g also. G of x, let's say, equals x squared plus 4x plus 3. All right, number 1, evaluate g of, let's just cut to a chase here, g of negative 2. First of all, what does that mean? Well, that's saying input negative 2. So into the expression here, defining expression sometimes it's called, I'm going to input negative 2, which just means replace the x by negative 2. Now notice here, x is in 2 places. It goes in both places, right? So I'm going to input negative 2 here and negative 2 here. And be careful with the signs. Okay, that was one thing I did notice on the last set homework it graded, but be sure to get the signs here right, because when I input negative 2 here, doesn't that mean negative 2 squared means I square the negative and the 2? All right, be careful with that. And then I'm going to do 4 times negative 2, and then I'm going to do the plus 3. Okay? What is negative 2 squared? It's positive 4, yes. I am squaring the negative with that. This one, 4 times negative 2 is negative 8, plus the 3, so you get 4 minus 8 plus 3. So g of negative 2 winds up being, that's negative 4 plus 3 is negative 1. G of negative 2 is negative 1. All right. Now, what they'll do is also, we've inputted several of these. We inputted just numbers. But you don't have to just input numbers. you can input actually other expressions. Say I want to evaluate g of x plus 4. Well, if I do g of x plus 4, it means the very same thing. What's my input value on this one? Well, the input value here is x plus 4. So just like over here, I inputted negative 2 in each place. Now, what do I input? I input instead an expression, x plus 4. So wherever x is, I'm going to input x plus 4 instead of negative 2. So g of x plus 4 means I'm going to input x plus 4 for x, so that's going to be x plus 4 squared, isn't it? Plus 4 times, well, I'm going to input x plus 4, so that's going to be 4 times x plus 4. And then the plus 3 comes up on the end. Yeah, so this obviously looks different. What do I do with it? Really, all you're going to do with it is simplify it. I don't know if we talked about this yet. I think it actually came up in the homework, but what x plus 4 squared, what I recommend when you do that is write it twice, and x plus 4 squared means two x plus 4s, right? And then FOIL. X plus 4 squared, write it twice, and then FOIL. You know what I mean by that? FOIL that out, so that would be x times x is x squared, x times 4 is 4x, 4 times x is 4x, and then 4 times 4, 16. Yeah, write it twice and FOIL it for that. Then I'll have, well, let me move that over a little bit. Run out of board space over there. Well, then I have to distribute the 4, so that would be 4x plus 16, right? 4 times x, 4 times 4, and then plus 3. And yeah, all I can do with that is combine the like terms. I've got x squared. I got 4x, 4x, and 4x. That's 12x, isn't it? Then I've got 16, 16, and 3, 35. Can't combine any more terms. This really isn't an equal 0 equation. That's it. That's all I can do with that. That's as far. Yeah, if you get an expression, usually a lot of times that's about all you can do with it. Just simplify it. There's no solving out that you're going to do to get an actual number there. So, okay. All right. Let me mention this one. Is that one a function? Yes, it's in function notation, but notice here, my input value is what? It is t, okay? The input value doesn't have to be x. It can be t, it can be whatever. It's just kind of an option. Usually it's x, but in this case, this is a function, the input value is t. Well, that's good because over here I've got the t value there. So if I wanted to do f of, let's say f of, what would be a good one, f of 17. What would f of 17 be? Well, that means input 17 for t, so that would be the square root of 17 plus 8, square root of 25, which is 5. If I do f of negative 1, that would be square root of negative 1 plus 8, just plugging in negative 1, so it would be the square root of 7. And that doesn't simplify anymore, so I'm just going to leave it square root of 7. What would f of 5x minus 1 be? What would I get there? Well, that would be inputting 5x minus 1 in place of the t, so that would be the square root of 5x minus 1 plus 8, right? What can I do with that? pretty much just combine combine like terms there, just minus 1 plus the 8, so square root of 5x plus 7 is what I would get there for input value 5x minus 1. With me on that? Any question or concern? All right, let me go back a little bit. Another definition here. Let's talk about domain and range. What we mean by domain and range, domain is this. It's the set of inputs in your function or relation, and the range is the set of outputs. Domain is a set of inputs, range is a set of outputs. Yeah, it's just names given to those particular sets. So if I'm back to back to a table, and I'll use x and y since we've used them as inputs, outputs now a lot. Let's say my inputs, the x values are 5, 7, and 9, and over here the 5 goes with 6, the 7 goes with negative 8, and the 9 goes with negative 13. Well, the domain is just the set of inputs, so it'd be 5, 7, and 9. And if it's just numbers like that, they'll put them in set braces. Don't let that throw you off. That's just set braces it's called. So, but the domain is 5, 7, and 9. Then the range, what's the set of outputs? So it'd be 6, 8, negative 8, and negative 13. Okay? Is all what's meant by that. We'll have more to say about that some later on. Trying to think if there was anything. Basically, though, that's it. A domain, set of inputs, range, set of outputs. Like we'll talk a lot more about that next time, but